We are on lesson 2 of chapter 7, which is to solve multi-step equations. First, we're going to simplify before solving equations. Then we're going to solve equations that contain fractions, and then we'll do a real-world application. Being able to solve multi-step equations come in handy in many different parts of life. For example, if you were going to do a skate rental and you know it would cost you $3 plus $1.50 per hour, and you wanted your bill to be a total of $7.50, how many hours could you skate? Well, you can make hours your variable and then solve it. For example, we could do $1.50 per hour, so times h, plus the $3 that we pay originally, and then that would be our total bill of $7.50. By subtracting the constant that we have to pay no matter what from both sides, we would see that we have $4.50 to spend on the amount of time that we can skate, which is $1.50 per hour. Divide by the $1.50 per hour. 450 divided by 150 equals 3, so the hours equal 3. We can skate for 3 hours and spend a total of $7.50 on our bill. First, let's practice this part of the equations. We can simplify before solving them. So it says solve for the variable. We have 3x plus 5 plus 6x minus 7 equals 25. If you remember our first lesson where we simplified like terms, this 3x and 6x are like terms because they have the same variable and then the same exponent. So this 3x and 6x would be alike, so 3x plus 6x would be 9x. We have positive 5 and then negative 7, so 5 minus 7 would be negative 2 or minus 2, and that would equal 25. Add 2 to both sides to get rid of the 2, leaves us with 9x equals 27. Divide both sides by 9, so x would equal 3. So we solved for the variable. Now we can use distributive property to solve this. We have 3 times x and 3 times 10, so 3x, drop that plus sign, 30 plus 6 equals 12. Since the 30 and the 6 are like terms, we can add those. So we have 3x plus 36 equals 12. Now we could subtract the 36 from both sides. 12 minus 36 is negative 24, so we have 3x equals negative 24. Divide both sides by 3. Negative 24 divided by 3 equals negative 8. So x equals negative 8. So we've solved for variables both times. Now we can solve for the variable with this problem. We have a bunch of fractions. And if you're anything like the class of 2015, you hate working with fractions. So I'm actually going to help you out a little bit. How could we get rid of all the fractions in this problem? Well, what we could do is we could find the least common multiple and then multiply that times everything in this equation. 9, 3, 2, and 6, their least common multiple would be 18. Remember, you can draw this out if you want, all the multiples, and find the common one. But I can figure that out in my head that it would be 18. So we would multiply everything times 18. Then we could simplify this. 9 goes into 18 2 times. 3 goes into 18 6 times. 2 goes into 18 9 times. 18 goes into 6 3 times. 2 times 4 is 8, so 8p, plus 6 times 1 is 6p, minus 9 times 1 is 9, and that equals 3 times 11, which is 33. Now we can simplify this expression. 8p plus 6p are like terms, so that's 14p minus 9 equals 33. We could get rid of the constant here by adding the 9. That'd be 42. So 14p equals 42. If we divide both sides by 14, that'll solve for p. P will equal 3. So just a quick recap. We multiplied everything times the least common multiple. Everything. Even if there's not a fraction, you have to multiply that times the least common multiple. And then you get your equation without fractions, which is a lot easier. Then we could solve for p. Let's do a real-world application. It says, on the first day of her vacation, Carly rode her motorcycle m miles in 4 hours. On the second day, she rode twice as far in 7 hours. If her average speed for the 2 days was 62.8 miles per hour, how far did she ride on that first day? Round your answer to the nearest tenth of a mile. This is pretty similar to our first problem where we had that total amount, and then we had to figure out the variable that would make the equation work for that total. So if we go back to here, our average speed, or total amount here, was 62.8 miles per hour. So 62.8, a little over equal sign right here. Remember, miles per hour is miles divided by the hours. So in this equation, we could put the miles on top and then the hours on the bottom. And we could add the total amount of miles and then divide it by the total amount of hours. So the first day, she rode m miles. The second day, she rode twice as far. Twice as far as m is 2 times m. So if we add twice as far, that would be plus 2m. Then dividing by the hours, she rode it in 4 and then 7. So I add those together. Then here is our equation. If we simplify this, m plus 2m equals 3m. 4 plus 7 is 11. 3m divided by 11 equals 62.8. To get rid of this division, we can multiply times 11 on both sides. These cancel out. 62.8 times 11 on my calculator gives me 690.8. So I have 3m over here equals 690.8. So if we could solve for 1m, or how far she rode on the first day, which was just m miles, we can divide by 3. 690.8 divided by 3, once again on our calculators, gives us 230.26 with a line over it. So 230.26 with a line over it. If we're going to round that, that would become 230.3, and we'll say that's miles. So that's how far she rode on that first day, because it was only m miles, not 2m or anything like that.